So during brainstorming, we were wondering how do we make the new school the most environmentally friendly and green place we could possibly make. And we set out on the idea of taking the school we go to and basically identify all the problems and fix them. Meaning step 1 was to first create a list of everything our school did wrong. So step 2 is to buy AutoCAD and load our designs. So we designed an education edition of Minecraft because we don't have $1,000. I mean, somehow we ended up with the task of building a school. Still, we were able to set up like an open house kind of thing. We added NPCs along the way to bring you to the features of the school.
The first issue we came across was that of power. The problem is that most people tend to jump towards the clean power options, which we will get to. But first, it is important to understand the first way in which we can reduce carbon emissions: reduction. Our design features virtually wall-to-wall tinted glass panes and roof skylights that allow the passage of natural light into the building, thereby eliminating the need to have lights on during a sunny day.
Reduction also applies to what we use the electricity for. Our design incorporates LED lights in the place of conventional light bulbs, given that they are more energy efficient and thereby help to reduce carbon emissions.
Other than lighting, cooling systems are another high cost that we must consider. It is common knowledge that air conditioners are among the most inefficient in terms of energy consumption and carbon footprint. One solution that we explore is making the design as open as possible, allowing natural ventilation and thereby a cooler temperature. But then we thought, what cooler temperature? So the solution we came up with was dehumidifiers and mist fan systems. The temperature of a room is significantly reduced when the humidity is reduced, giving the sensation of a cooler environment. The water collected from the machine can be used for mist fans for additional cooling.
All the problems can be summed up essentially into 3 criteria commonly known as the energy trilemma. These being sustainability, strain on the environment, and energy equity or general accessibility. The frontrunners of our search are commonly known as the renewable energy sources: geothermal, solar, hydroelectric, and wind. The issue with these measures lie mainly in the third part of the trilemma, accessibility. Geothermal is only available to geological hotspots and plate boundaries. Solar highly depends on external factors such as time of day and weather conditions. Hydroelectric requires areas of high running water, and wind requires, well, wind. And really only one method is sustainable for Singapore.
Solar panels are installed on the majority of the wings so as to provide green, sustainable and available energy for everyone in the school. A separate building on the compound is solely dedicated to collecting and storing excess energy for, well, a rainy day. In that way, our school has the best electrical system that functions in shine or rain.
We maintain our previous idea of keeping our school in line with locavore ideals, where there is little to no distance from farm to table. As such, vegetables which are found in canteen food are grown in sky gardens atop the classroom, which cuts back on transport emissions otherwise. Water collection areas for rainwater are placed on the ground level of the block to serve as nourishment to the sky garden, as well as an aesthetically pleasing and cooling aspect of the building.
Plants are used elsewhere in the school in the form of green walls and outdoor gardens, which both serve to help reduce carbon emissions through natural photosynthesis and also cool the building. The water to nourish these are collected through porous or breathing roads, where during rain, water that falls on the road, or in this case the track, is not wasted to evaporation, rather it is taken for use.